Hello everyone, dear students, welcome back to the online classes. In this class I am going to explain what is magnetic field and what is magnetic field line and the properties of magnetic field lines. Magnetic field means the region around the magnet is called magnetic field. Suppose if you consider this is the bar magnet. In previous video already I discussed about what is bar magnet and what are the properties of the bar magnet. This is the bar magnet. It has a two pole. One is north pole and another one is south pole. A line passes through the magnetic north pole to the magnetic south pole. This is called magnetic axis. This is called magnetic axis, and a vertical line passes through the midpoint of this magnet. This is called magnetic equator. And other properties, the length between or the distance between the north pole and south pole inside this magnet, this is called magnetic length, and the actual length of the magnet is called, this is called geometrical length. All these properties already I discussed in the last class. And the region around the magnet is called magnetic field. It has a two pole, one is north pole and another one is south pole. When the iron pillings are sprinkled over this surface of this magnet, here the iron pillings are arranged themselves in the order of the concentric circles like this. These are the magnetic field lines. The region around the magnet is called magnetic field. On the magnet ಇದೆ, ಈ magnet ದ ಸುತ್ತಮುತ್ತಲು ಇರತಕ್ಕಂತ ರೀಜನ್ ಅನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. The region around the magnet is called magnetic field. And ಇಲ್ಲಿ ಇರತಕ್ಕಂತ ಲೈನ್ಸ್ ಗಳನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್. ಇಟ್ ಇಸ್ ವೆರಿ ಸಿಂಪಲ್. ನಿಮ್ಮ ಹತ್ರ ಒಂದು ಮ್ಯಾಗ್ನೆಟ್ ಇದೆ. ಆ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನು ನೀವು ಐರನ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇರತಕ್ಕಂಥವು, ಇದೊಂದು ಯಾವುದೋ ಒಂದು ಸರ್ಫೇಸ್ ಇದೆ, ಐರನ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅದು, ಇದರ ಒಂದು ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನ ತಂದಿಟ್ರಿ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಇರತಕ್ಕಂತ ಐರನ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಯಾವ ರೀತಿ ಅರೇಂಜ್ ಆಗ್ತಾವು? ಈ ಪಾತ್ ಅಲ್ಲಿ ಅವು ಅರೇಂಜ್ ಆಗ್ತವು. ದೀಸ್ ಆರ್ ದ ಇಮ್ಯಾಜಿನರಿ ಲೈನ್ಸ್. ದೀಸ್ ಆರ್ ಕಾಲ್ಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್. ಇವಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ ನಾವು? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್. ವಾಟ್ ಈಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್ imaginary path followed by a unit north pole placed at different points in the magnetic field. Imaginary path followed by a unit north pole. Unit north pole placed at different points in the magnetic field. Different points in the magnetic field. Magnetic field lines are the imaginary lines. These are the imaginary lines, or these are the imaginary loops used to represent the magnetic field of this magnet. Magnetic field lines are imaginary loops used to represent the magnetic field of a magnet. And these are the imaginary loops used to represent the magnetic field of a magnet, and the tangent drawn at any point on the field line, it represents the direction of the magnetic field at that point. Suppose if you draw the tangent at this point, here it represents the direction, it represents the direction, and this point it represents the direction. Here this is the bar magnet. It has a two pole, one is north pole and another one is south pole. ಇಲ್ಲಿ ಇರ್ತಕ್ಕಂಥದ್ದು here magnetic field lines due to the bar magnet. ಇಲ್ಲೊಂದು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನು ಇಟ್ಟಿವಿ. ಈ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಇಂದ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಕ್ಕಂಥ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಇವು, ಹೌದಾ? And ಇಲ್ಲಿ magnetic field due to a current carrying finite solenoid. The current carrying conductor acts as a solenoid. Here this is the conductor. When the current flowing through the conductor, the magnetic field is produced. Already all these concepts you have studied in your moving charges and magnetism topic, right? Magnetic field lines are the imaginary loops used to represent the magnetic field of a magnet, or the imaginary path followed by unit north pole placed at different points in the magnetic field. It is called magnetic field line. ಇಲ್ಲಿ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡ್ರಿ, simple. What are the properties of magnetic field line? Magnetic field lines starts their journey from north pole. Starts their journey from north pole to south pole. ಎಲ್ಲಿಂದ ಎಲ್ಲಿವರೆಗೆ ಬಂದವು ನೋಡ್ರಿ magnetic field lines. Magnetic field lines starts their journey from north pole and it reaches the south pole externally. ನಾರ್ತ್ ಪೋಲ್ ಇಂದ ಸೌತ್ ಪೋಲ್ ಬರಬೇಕಾದ್ರೆ ಏನಾಗುತ್ತೆ ಎಕ್ಸ್ಟರ್ನಲಿ ಇಲ್ಲಿಂದ ಕೂಡ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಸ್ಟಾರ್ಟ್ಸ್ ದೇರ್ ಜರ್ನಿ ಫ್ರಮ್ ನಾರ್ತ್ ಪೋಲ್ ಅಂಡ್ ರೀಚಸ್ ದ ಸೌತ್ ಪೋಲ್ ಎಕ್ಸ್ಟರ್ನಲಿ. ನಾರ್ತ್ ಪೋಲ್ ಇಂದ ಸೌತ್ ಪೋಲಿಗೆ ಬರಬೇಕಾದ್ರೆ ಏನಾಗ್ತವೆ ಎಕ್ಸ್ಟರ್ನಲ್ ಆಗಿ ಬರ್ತವೆ. ಅಂಡ್ ಸೌತ್ ಪೋಲ್ ಟು ನಾರ್ತ್ ಪೋಲ್ ಇಂಟರ್ನಲಿ, ನಾರ್ತ್ ಪೋಲ್ ಇಂದ ಸೌತ್ ಪೋಲ್ ವರೆಗೆ ಹೋಗ್ಬೇಕಾದ್ರೆ ಏನಾಗ್ತವೆ ಇಂಟರ್ನಲ್ ಆಗ್ತವೆ. This is the first property. Magnetic field lines are starts their journey from north pole and to reach the south pole externally and south to north internally. It is the first property. And the second property of this magnetic field line is a tangent drawn at any point on the magnetic field line. ನಾನು ಇಲ್ಲಿ ಡ್ರಾ ಮಾಡ್ಬೋದು, ಇಲ್ಲಿ ಡ್ರಾ ಮಾಡ್ಬೋದು, ಇಲ್ಲಿ ಡ್ರಾ ಮಾಡ್ಬೋದು. ನಾನು ಎಲ್ಲಿ ಡ್ರಾ ಮಾಡ್ತೀನಿ ಆ ಪಾಯಿಂಟನ್ನು ನಾನು ಏನಂತ ಕರಿತೀನಿ, it represents the direction of the magnetic field at that point. ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಾನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಯಾವುದೈತಿ, ಇಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ಯಾವುದೈತಿ, ಇಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ಯಾವ್ದು. ನಾನು ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಟ್ಯಾಂಜೆಂಟ್ ಡ್ರಾನ್ ಅಟ್ ಎನಿ ಪಾಯಿಂಟ್ ಆನ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್, ಇಟ್ ರೆಪ್ರೆಸೆಂಟ್ಸ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಟ್ ದಟ್ ಪಾಯಿಂಟ್. ಅಂಡ್ ನೋ ಟೂ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಇಂಟರ್ಸೆಕ್ಟ್. ಇಲ್ಲಿ ನೋಡ್ರಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಅದಾವ, ಇಲ್ಲೊಂದು this is the first magnetic field, second magnetic field line, third magnetic field line and fourth magnetic field line. Here also this is the first one, second one, third one and fourth one. No two magnetic field lines or cannot intersect each other. ಎರಡು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗಕ್ಕೆ ಪಾಸಿಬಿಲಿಟಿ ಇಲ್ಲ. ಮೊದಲನೇ ಪ್ರಾಪರ್ಟಿ ಏನು, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಸ್ಟಾರ್ಟ್ಸ್ ದೇರ್ ಜರ್ನಿ ಫ್ರಮ್ ನಾರ್ತ್ ಪೋಲ್ and it reaches the south pole externally, south pole to north pole internally. Second property is a tangent drawn at any point on the surface of the magnetic field. It represents the direction of the magnetic field lines. The third property is no two magnetic field lines intersect each other. ಎರಡು magnetic field lines intersect ಆಗಕ್ಕೆ possibility ಇಲ್ಲ. No two magnetic field lines intersect each other. And the fourth property is the n number of magnetic field lines crossing per unit area. It depends on the strength of the magnetic field. It depends on the strength of the magnetic field. And magnetic field lines are overcrowded in the region of north and south pole of the magnet. Magnetic field lines are overcrowded in the region of north and south pole of the magnet and less crowded in the other region. ಇಲ್ಲಿ ನಾರ್ತ್ ಮತ್ತು ಸೌತ್ ಪೋಲ್ ಇದ್ದಲ್ಲಿ ಯಾಕೆ ಓವರ್ ಕ್ರೌಡೆಡ್ ಆಗಿರ್ತಾವೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಅಂದ್ರೆ, ಹಿಯರ್ ದ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಇಸ್ ವೆರಿ ಮೋರ್, ದ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ವೆರಿ ಹೈ. The strength of the magnetic field is very high and it obeys the inverse square law. If the distance is increases, the magnetic field is decreases. If the distance is decreases, the magnetic field is increases. It obeys the inverse square law. Now we will see some more important properties of this magnetic field line. The first property is magnetic field lines start from the north pole and reach the south pole externally and then go from south pole to north pole internally in a magnet. That's why the magnetic field lines are called continuous closed loop. Illondu magnet ide, it has a two pole, one is north and another one is south. Illinda start agi enagutte namaga illi end agutte. Magnetic field lines start from north pole and it reaches the south pole externally and then go from south pole to north pole internally. Illinda illi internal agi move agutte. Ee kade idru kuda ashte line, illi ellavu kuda enagtave internal agi move aguttave. Two magnetic field lines cannot intersect each other. And a tangent drawn at a point on the magnetic field line, illi nanu elle tangent draw madidru kuda it represents the direction of the magnetic field at that point. And two magnetic field lines never intersect each other. If they intersect, then at the point of intersection there will be the two tangents indicating two direction of the magnetic field, which is not possible. ಹೌದಾ, ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗ ಪಾಸಿಬಿಲಿಟಿ ಇಲ್ಲ. And magnetic field lines are less apart and overcrowded in the region of the strong magnetic field. ಎಲ್ಲಿ ಸ್ಟ್ರಾಂಗ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೋ, where the magnetic field is very high, in that region magnetic field lines are less apart. Magnetic field lines are less apart. ಒಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಇಂದ ಇನ್ನೊಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಗೆ ಡಿಸ್ಟನ್ಸ್ ಕಡಿಮೆ ಇತ್ತು ಅಂದ್ರೆ ಆ ರೀಸನ್ ಅನ್ನು ಏನಂತ ಕರಿತೀವಿ ನಾವು ಸ್ಟ್ರಾಂಗರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್ ಲೆಸ್ ಅಪಾರ್ಟ್ ಅಂಡ್ ಓವರ್ ಕ್ರೌಡೆಡ್ ಇನ್ ದ ರೀಸನ್ ಆಫ್ ಸ್ಟ್ರಾಂಗ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ಅಂಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್ ಫಾರ್ ಅಪಾರ್ಟ್ ಅಂಡ್ ಲೆಸ್ ಕ್ರೌಡೆಡ್ ಇನ್ ದ ರೀಸನ್ ಆಫ್ ವೀಕರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಎಲ್ಲಿ ವೀಕ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೋ ಅಲ್ಲಿ ಒಂದು ಲೈನಿಂದ ಇನ್ನೊಂದು ಲೈನ್ ಡಿಸ್ಟೆನ್ಸ್ ದೂರ ಇರುತ್ತೆ, ಕ್ರೌಡು ಕೂಡ ಏನಾಗಿರುತ್ತೆ ಕಡಿಮೆ ಇರುತ್ತೆ. ಅಂಥ ರೀಸನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ ವೀಕ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ನಾವು ಕರಿತೀವಿ. ಆ್ಯಂಡ್ ಸಮ್ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಾಪರ್ಟೀಸ್. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಹ್ಯಾವ್ ಎ tendency to contract in length, and this property explains the attractive nature of force between the unlike poles. Like poles are repel each other, unlike poles are attract each other. Field lines have tendency to contract in length. ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಏನಾಗ್ತಿರ್ತಾವು ಟೆಂಡೆನ್ಸಿ ಮೀನ್ಸ್ ಟ್ರೈ ಟು ಕಾಂಟ್ರಾಕ್ಟ್ ಇನ್ ಲೆಂತ್, ಆ ಲೆಂತ್ ಅನ್ನು ಫಾರ್ಮ್ ಮಾಡೋಕೆ ಟ್ರೈ ಮಾಡ್ತಿರ್ತಾವೆ. ಅಟ್ರಾಕ್ಟಿವ್ ನೇಚರ್ ಆಫ್ ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಅನ್ಲೈಕ್ ಪೋಲ್ಸ್, ಎರಡು ಪೋಲ್ಗಳ ಮಧ್ಯೆ ಅಟ್ರಾಕ್ಟಿವ್ ಪ್ರಾಪರ್ಟಿ ಇರುತ್ತೆ, ಹೌದಾ? ಬಿಕಾಸ್ ಒಂದು ನಾರ್ತ್ ಪೋಲ್ ಇನ್ನೊಂದು ಸೌತ್ ಪೋಲ್ ಎರಡು ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಿರ್ತಾವೆ. ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಿರ್ತಕ್ಕಂಥ ಸಂದರ್ಭದಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಹ್ಯಾವ್ ಟೆಂಡೆನ್ಸಿ ಟು ಕಾಂಟ್ರಾಕ್ಟ್ ಇನ್ ದ ಲೆಂತ್. ಆ್ಯಂಡ್ ದ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಹ್ಯಾವ್ ಟೆಂಡೆನ್ಸಿ ಟು ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಇನ್ ಲೆಂತ್. ಈ ಪ್ರಾಪರ್ಟಿನೂ ಕೂಡ ಇರುತ್ತೆ. ಅಟ್ರಾಕ್ಟ್ ಇದ್ದಾಗ ಏನಾಗ್ತಾವು ಕಾಂಟ್ರಾಕ್ಟ್ ಇನ್ ಲೆಂತ್. ಅಟ್ರಾಕ್ಷನ್ ಆಗಬೇಕಾಗಿತ್ತು ಅಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸು ಕಾಂಟ್ರಾಕ್ಟಲ್ಲಿ ಬರ್ತಾವೆ, ಒಂದಕ್ಕೊಂದು ಸಮೀಪ ಬರ್ತಾವೆ. ರಿಪಲ್ಷನ್ ಆಗಬೇಕಾಗಿತ್ತು ಅಂದರೆ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಇನ್ ಲೆಂತ್. ಒಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸು ಇನ್ನೊಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸು ದೂರ ಹೋಗೋಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಿರ್ತಾವೆ. ಇಟ್ ಈಸ್ ಅ ವೆರಿ ಸಿಂಪಲ್ ಕಾನ್ಸೆಪ್ಟ್, ಹೌದಾ? ಅಟ್ರಾಕ್ಟಿವ್ ಪ್ರಾಪರ್ಟಿ ಇತ್ತು ಅಂತಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸು ಕಾಂಟ್ರಾಕ್ಟ್ ಆಗಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾವು. ರಿಪಲ್ಸಿವ್ ಇತ್ತು ಅಂದರೆ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಆಗಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾವೆ, ಹೌದಾ? ದಿಸ್ ಈಸ್ ವೆರಿ ಸಿಂಪಲ್ ಕಾನ್ಸೆಪ್ಟ್. ಆ್ಯಂಡ್ ದ ಏರ್ತ್ ಪ್ರಾಪರ್ಟೀಸ್, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್ ಸ್ಟ್ರೈಟ್, equidistant and parallel in uniform magnetic field. Parallel in uniform magnetic field like this. Here this is the reason of uniform magnetic field. Uniform magnetic field means the magnetic field is equally distributed throughout the region. In this region magnetic field lines are straight, equidistant and parallel in uniform magnetic field and curved like this. ಹೌದಾ? ಈ ರೀತಿಯಾಗಿತ್ತು ಅಂತಂದ್ರೆ curved. In case of natural magnet, this is the in case of natural magnet and this is artificial magnet. Natural magnet ಅನ್ನು ತಗೊಂಡಾಗ magnetic field lines are curved, that represents the non-uniform magnetic field. ಅದನ್ನು ನಾವು man made magnet, artificial magnet ಮಾಡಿದಾಗ ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ ಅದು ಯೂನಿಫಾರ್ಮ್ ಆಗಿರುತ್ತೆ. Magnetic field lines are straight, equidistant and parallel in uniform magnetic field, and magnetic field lines are curved in non-uniform magnetic field. These are the properties of magnetic field lines. The properties of magnetic field lines. And the next concept is current solenoid acts as a magnetic dipole or a bar magnet. Suppose if I consider this is the solenoid. What is solenoid? Solenoid is a circular current carrying wire. Circular current carrying wire. It consists of n number of turns. These are the n number of turns. When the current move inside this solenoid, here this into mark, it represents current move into the plane of this paper, and the dotted line, it indicates current exits outside the plane of this paper. This solenoid acts as a magnetic dipole or it acts as a bar magnet. What is the relation between moving charges and magnetism? Overstud explain. There is a relation between electricity and magnetism. When the current flows through a conductor, the magnetic field is produced. Here, this particular diagram, it represents the current solenoid as a magnetic dipole. ಒಂದು solenoid dipole ಆಗಿ ಯಾವ ರೀತಿ ಆಕ್ಟ್ ಮಾಡುತ್ತೆ ಅಂತಕ್ಕಂಥ ಕಾನ್ಸೆಪ್ಟ್ ನಲ್ಲಿ ಕೊಟ್ಟನು. The current moves in the anti-clockwise direction. Anti-clockwise direction. Then one pole, it acts as a, this is the south pole and this is the north pole. One end of the solenoid, it represents the south pole. It represents the south pole. Magnetic field lines always start their journey from north pole to south pole externally, south pole to north pole internally. Here, north pole to south pole externally, south pole to north pole internally. Here also, magnetic field lines north pole to south pole externally and south pole to north pole internally. This is the imaginary concept. Current solenoid acts as a magnetic dipole or a bar magnet. Right, this is the bar magnet. It has a two pole. You get the clear idea in this diagram, right? And this is the solenoid. It acts as a bar magnet. See here, right? Observe this phenomena. It acts as a bar magnet. That's why we say current solenoid as a magnetic dipole or a bar magnet. Okay. Now we will move to the next concept. Torque on a magnetic dipole or bar magnet in a uniform magnetic field. Uniform magnetic field means it is the region in which the magnetic field is equally distributed throughout the region. The uniform magnetic field lines are always moving in the straight path with equidistant and parallel to one another. In that uniform magnetic field, now we will place the bar magnet or a magnetic dipole. When the bar magnet is placed in the region of uniform magnetic field, the torque is produced due to the uniform magnetic field. Now we will find that value. This is the region of uniform magnetic field. This is the region of uniform magnetic field. Consider a uniform magnetic field and a bar magnet or magnetic dipole is placed in the region of uniform magnetic field. This is the magnetic dipole. The magnetic dipole is placed in the region of uniform magnetic field. It has a two pole. One is north pole and another one is south pole. The north pole, it is due to the Coulombian attractive force and Coulombian repulsive force. North pole, it is moving in this direction because north pole acts as a positive and south pole acts as a negative, right? Here this is the region of uniform magnetic field. In this uniform magnetic field, now we will place the bar magnet or magnetic dipole is placed in the region of uniform magnetic field. M is the magnetic length. Magnetic length means the distance between the north pole and south pole in a magnet is called magnetic length. And this is the perpendicular line, and theta is the angle between the magnetic field to the magnetic length or where the north and south poles are situated. 2L is the magnetic length. The forces of magnitude MB. The forces of magnitude MB. MB, B means magnetic field, M means magnetic dipole. The forces of magnitude MB act opposite to each other. Opposite ಆಗಿ ಆಕ್ಟ್ ಆಗ್ತವೆ ಯಾಕಂದ್ರೆ ಎರಡು ಒಂದು ನಾರ್ತ್ ಪೋಲ್ ಇರುತ್ತೆ ಇನ್ನೊಂದು ಸೌತ್ ಪೋಲ್ ಇರುತ್ತೆ ಅಲ್ಟಿಮೇಟ್ಲಿ ಅಪೋಸಿಟ್ ಆಗಿ ಆಕ್ಟ್ ಆಗ್ತವೆ. Hence the net force acting on this magnet due to the external uniform magnetic field is zero. Net force acting on this bar magnet due to external magnetic field is zero and therefore no translational motion of the magnet. ಈ magnet ಅನ್ನು ಇಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡಿದೀವಿ ಅಂದ್ರೆ ಅದು ಇದೇ ರೀತಿ ನಿಲ್ಲತ್ತ because due to the opposite force. Due to this opposite force the torque is produced. Here the forces are along the different line of action and it constitute a couple. Hence the magnet will rotate and experience a torque. Torque, it is nothing but twisting force and it is the product of force and perpendicular distance. Here this force and perpendicular distance, the product of force and perpendicular distance is called torque. Due to the force and perpendicular distance, the torque is produced. It is also very simple concept. ಇಲ್ಲಿ ಯೂನಿಫಾರ್ಮ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ರೀಸನ್ ಅಲ್ಲಿ ಒಂದು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನು ಇಟ್ಟಾಗ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಮೇಲೆ ಏನಾಗ್ತವೆ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತವೆ, ಅಪೋಸಿಟ್ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತವೆ ಅಂಡ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಏನಾಗುತ್ತೆ ಜೀರೋ ಆಗುತ್ತೆ. ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಜೀರೋ ಆಯಿತು ಅಂದ್ರೆ ನೋ ಟ್ರಾನ್ಸ್ಲೇಷನ್ ಮೋಷನ್, ಮ್ಯಾಗ್ನೆಟ್ ಮೂವ್ ಆಗೋಕ್ಕೆ ಪಾಸಿಬಿಲಿಟಿ ಇಲ್ಲ. ಅಂಡ್ ಫೋರ್ಸ್ ಆಕ್ಟಿಂಗ್ ಅಲಾಂಗ್ ದ ಡಿಫರೆಂಟ್ ಲೈನ್ ಆಫ್ ದಿಸ್ ಆಕ್ಷನ್ ಅಂಡ್ it produces certain constitute a couple it is nothing but twisting force and it rotate and experience a torque. Now I am going to calculate the value of torque. Torque is equal to magnetic force into perpendicular distance. Magnetic force into perpendicular distance. This is the magnetic force into perpendicular distance. Magnetic force in the value mb. Magnetic force is mb. Perpendicular distance, the magnetic length. Here this is in the form of triangle. It is in the form of triangle. magnetic length. Perpendicular distance, this is a magnetic length, and this is a perpendicular distance. This is a sine angle because sine theta is equal to opposite divided by hypotenuse. Sine theta is equal to opposite divided by hypotenuse, right? 2L into sine theta. 2L into sine theta. Magnetic force into perpendicular distance, that is magnetic force is MB. Plus MB or minus MB. Plus and minus, they are opposite signs. But the magnetic force is only MB into 2L sine theta. But we know the formula. We know the formula. The product of magnetic force into magnetic length, M into 2L. The product of force strength and magnetic length is called magnetic dipole moment, capital M. M into B sine theta. M into B sine theta. M into 2L is equal to M. M into 2L is equal to M. That is called torque is equal to M cross B, because A cross B is equal to AB sine theta. A cross B is equal to AB sine theta. Here magnetic force is, that is M into B, and perpendicular distance is 2L sine theta, or M into L, M into 2L into B sine theta. Here the product of the pole strength and magnetic length. Pole strength, it is also denoted as QM. QM anta denote madadana ನಾವು ಇಲ್ಲಿ ಏನು ತಗೊಂಡಿವಿ, MB ಅಂತ ತಗೊಂಡಿವಿ. QM, the product of pole strength and magnetic length, or the product of the magnetic force and this length. This is mathematically denoted by the symbol M. M means magnetic dipole moment. MB sine theta. It is in the form of AB sine theta. Here A cross B is equal to AB sine theta. Therefore torque is equal to MB sine theta. Vector torque is equal to vector M cross vector B. Right? Here B is the vector quantity and M, this is also vector quantity. Theta is the angle between the magnetic field and magnetic dipole moment. T is the torque. The torque is produced. The definition of the torque, or the direction of the torque, is perpendicular and into the plane containing M and D, and plane containing M and D. In the next class I will discuss the work done, or the expression for magnetic field lines in terms of frequency and period of oscillating of magnetic compass needle in uniform magnetic field. From using that equation, we will calculate the expression for potential energy stored in the magnetic needle and rotated in the magnetic field with the special cases. Okay, thank you.